P conjunction Q disjunction R is logically equivalent to P conjunction Q disjunction P conjunction R. So these are called as distributive laws, very important. Now write down the truth values. As you know, the truth values for this P are true, true, false, false. For it is true, false, true, false. So again for disjunction, false and false is false. In other cases it is true. So false and true is true. True and true is also true. False and false is false. True and false is true. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So in my previous class we have discussed regarding the construction of truth table. So and verifying whether the given proposition is a tautology, contradiction or neither tautology nor contradiction. So in this session I am going to discuss regarding the last concept, that is logically equivalence. So today I am going to discuss regarding logically equivalence. Now we have to verify whether the given compound propositions are logically equivalent. Any two compound propositions are logically equivalent. So to verify whether the two given compound propositions are logically equivalent means just find out the truth values for the first equation and similarly for the second equation. If the two compound proposition will have the same truth values, then we are going to call it as logically equivalent. So A is logically equivalent to B. A is logically equivalent to B, or we can also write A is logically equivalent to B. Now let us know what is the meaning of logically equivalence. So that is logically equivalence, two compound proposition P and Q involving the same components are said to be logically equivalent if their truth values are same for different combinations of the truth values of their components. So we are going to represent this logically equivalence as P is logically equivalent to P is logically equivalent to Q. That is A is logically equivalent to B. That means if two compound propositions, any two compound propositions, say P and Q are two compound propositions, or A and B are any two compound proposition involving the same components are said to be logically equivalent when if their truth values are same for each different combinations. The truth values are same for each different combinations of the truth values of their components, then they are said to be logically equivalent, and logically equivalent is symbolically denoted as P is logically equivalent to Q or A is logically equivalent to B, right? Now there are certain properties. So some important logically equivalent propositions are demopotent law, that is P disjunction P is also equal to P, P conjunction P is also equal to P. So that is P disjunction P is equal to P and P conjunction P is also equal to P. Similarly, law of double negation. Negation of a negation is equal to P itself. Negation of a negation, that is called double negation. Negation of negation P is equal to P. Now, commutative law. Commutative law means, so that is P disjunction Q is also equal to Q disjunction P, or P conjunction Q is also equal to Q conjunction P. That is A disjunction B is also equal to B disjunction A, or conjunction P conjunction Q is also equal to Q conjunction P. Let me explain. Now let us know regarding the third one, associative law. So associative law. So for associative law, suppose if it is P disjunction Q disjunction R, this can also be written as, so P disjunction Q disjunction R, just interchanging the brackets, that is P disjunction Q disjunction R is equal to P disjunction Q disjunction R, or in case of conjunction P conjunction Q conjunction R is equal to P conjunction Q conjunction R. So these are called as associative laws. Okay, that means, so this is very important. What are associative laws? That is P disjunction Q disjunction R is logically equivalent to P disjunction Q disjunction R, or P conjunction Q conjunction R is also logically equivalent to P conjunction Q conjunction R. These are called as the associative laws. Okay. Now, next one. Move on to the next one. Distributive laws. What are distributive laws? So, in distributive laws, we have conjunction and disjunction. P disjunction Q conjunction R is equal to P disjunction Q conjunction P disjunction R. Similarly, in case of conjunction, P conjunction Q disjunction R is logically equivalent to P conjunction Q disjunction P conjunction R. So, these are called as distributive laws. Very important. So, P conjunction Q disjunction R is logically equivalent to P conjunction Q disjunction P conjunction R. Right. Now, De Morgan's law. What is De Morgan's law? This is also very important. You may expect one question from De Morgan's law or from distributive law. So, negation of P conditional to Q is logically equivalent to P conjunction negation Q. Negation of P disjunction Q is logically equivalent to negation P conjunction negation Q. So, very important laws. De Morgan's law, negation of P conjunction Q. Negation of P conditional to Q. Negation of P conditional to Q is equal to, is logically equivalent to P conjunction negation Q. Negation of conditional is P conjunction negation Q. Similarly, negation of P disjunction Q is negation P conjunction negation Q. See the difference. Negation of P conditional to Q is P conjunction negation Q. Whereas negation of P disjunction Q is logically equivalent to negation P conjunction negation Q. So, these are distributive law, De Morgan's law. Okay. Similarly, suppose if it is like this. Third one, negation of P conjunction Q. Negation. So, this is disjunction. Negation is logically equivalent to negation P disjunction negation Q. See here. So, this is negation of P disjunction Q. Suppose if it is negation of P conjunction Q, negation of P conjunction Q is also logically equivalent to negation P disjunction negation Q. So, these are all De Morgan's law. Okay. Now, next move on to the next one. Negation of a conditional. So, this is negation of a conditional. So, negation of a conditional and these are called as De Morgan's law. Negation of a conditional is negation of P conditional to Q is logically equivalent to P conjunction negation Q. Negation of a biconditional. Negation of biconditional is negation of P biconditional to Q is logically equivalent to P conjunction negation Q disjunction Q conjunction negation P. Negation of biconditional statement, that is P biconditional to Q whose negation is logically equivalent to P conjunction negation Q disjunction Q conjunction negation P. So, this is negation of a biconditional and a conditional statement. So, this is nothing but the negation of a conditional statement, and these are called as the De Morgan's law. Negation of P disjunction Q is logically equivalent to P conjunction negation Q. Negation of P disjunction Q is logically equivalent to negation P disjunction negation Q. So, De Morgan's law and negation of a conditional statement and biconditional statements. Now, based on this, let us move on to the problems. Now, let us take a first problem. Prove that, so this is very important for 5 marks. Prove that negation of P conditional to Q is logically equivalent to P conjunction negation Q. So, negation of a conditional statement. Now, what is to verify? Negation of P conditional to Q is logically equivalent to P conjunction negation Q. Now, let's write PQ negation of Q. PQ negation of Q. First statement is P conditional to Q and the negation of P conditional to Q. Then P conjunction negation Q. Okay. Now, what are the truth values? As you know, the truth values for this is true, true, false, false. Here it is true, false, true, false. So, the truth values for P are T, T, F, F. For Q it is T, F, T, F. Now, write down the negation of Q. Negation of T is F, F it is T, T is F, F it is T. Negation. Now, write down the conditional for these two. What is the conditional statement? If true and false is there means then it is false. In all other cases it is true. So, true and false is false. In all other cases it is true. So, true and true is true. True and false is false. False and true is also true. False and false is also true. Now, the negation of this conditional. Negation of T is F, F is T, T is F, T is F. So F, T, F, F. So the negation of T is F, F is T, negation of T is F, negation of T is F. Now write down the conjunction for P and negation Q. So the conjunction for these two. Conjunction. Conjunction means true and true is true. In all cases it is false. So true and true is true. Now just write down the conjunction for P and negation Q. For these two we are going to write the conjunction. So what is the condition? If both the statements are true, then it is true. True and true is true. In all other cases it is false in case of conjunction. True and false is false. Again, true and true is true. Again, false and false is also false. False and true is also false. See, just observe carefully. This is first column, second column, third column, fourth column, fifth column and sixth column. So if you observe carefully, column 5 and column 6 will have the same truth values. So column 5 have F, T, F, F. Column 6 have F, T, F, F. These two columns are same. That means these two statements are logically equivalent. So since sixth column is equal to seventh column, that is the truth values. Truth values of sixth column is equal to seventh column. That means all the truth values in sixth and seventh column are same. Therefore, they are logically equivalent. So, therefore, what you say? Negation of P conditional to Q is logically equivalent to P conjunction negation Q. This is how we are going to verify. So, these two are logically equivalent. Suppose if I call this as A and B, A is logically equivalent to B. That's it. So, if you prove this much, definitely you will get 5 marks. Hope you followed. Move on to the similar type problem. Now, examine whether the following are logically equivalent or not. P conjunction negation Q disjunction Q and P disjunction Q. So, whether these two are logically equivalent or not. So, what is to verify? To prove that P conjunction negation Q disjunction Q is logically equivalent to P disjunction Q. We have to verify this. Now, write on the value. So, here first P, then Q. Let us write first P, then Q, negation of Q, then P conjunction negation Q, again P conjunction negation Q, disjunction Q, again P disjunction Q. So, P, Q, negation Q, P conjunction negation Q, P conjunction negation Q, again disjunction of Q, P conjunction negation Q, disjunction Q and P disjunction Q. Now, write on the truth values. As you know, the truth values for this P are true, true, false, false. For it is true, false, true, false. Negation of Q means false, true, false, true. Right? False, true, false, true. Now, conjunction for P and negation Q. For these two conjunction means true and true is true. In all cases, it is false. T and F is F. T and T is T. F and F is F. F and T is also F. So, true and true is true. In all cases, it is false. Now, write down the disjunction for these two. P conjunction negation Q, disjunction Q. So, these two, for these two, write down the disjunction for these two. P conjunction negation Q, disjunction Q. So, that is in case of disjunction, false and false is false. In all cases, it is true. So, false and true is true. Again, true and false is also true. False and true is also true. False and false is false. So, between these two, P conjunction negation Q, disjunction Q means false and true is true. True and false is also true. False and true is also true. False and false is false. Now, write down the disjunction for these two. What is disjunction? False and false is false. In all cases, it is true. True and true is true. Again, true and false is also true. False and true is also true. False and false is equal to false. Observe carefully. So, if you represent this as first column, second column, third column, fourth, 5, sixth column. So, the truth values in fifth and sixth column are same. T, 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 F, F. So, the truth values in fifth column and sixth column are same. So therefore they are logically equivalent. So truth values of 6th and 7th, 6th column is equal to 7th column. The truth values of 6th and 7th column are same. Therefore we can say that P conjunction negation Q disjunction Q is logically equivalent to P disjunction Q. That is, this is the answer. P conjunction negation Q disjunction Q is logically equivalent to P disjunction Q. That means these two statements are logically equivalent. Now move on to the next problem. P biconditional to Q and negation P disjunction Q conjunction negation Q disjunction P are logically equivalent. Now we have to verify. Let us call this as A and this as B. A is logically equivalent to B. What is A? Biconditional to Q. P biconditional to Q. What is B? Negation P disjunction Q conjunction negation Q disjunction P. Now let us split P Q. P biconditional to Q negation P negation of P disjunction Q, again negation Q disjunction P and the conjunction for these two. Now write down the truth values. So as usual the truth values for P are true, true, false, false, T, F, 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 T, T, F, F. For Q it is true, false, true, false. Biconditional, biconditional means if both are true, true. If both are false then it is true. In other cases it is false. So true and true is true. True and false is false, false and true is false, false and false is also equal to true. Now, negation of P, negation of P, for T it is F, for T it is F, for F it is T and T. Negation of P is F, F, T, T. Now, negation of P, disjunction Q, negation of P and disjunction Q, the disjunction for these two. So, disjunction means what? False and false is false, in all cases it is true. So, false and true is true. False and false is false, true and true is true, true and false is also true. So, negation P, disjunction Q means false and true is true, false and false is false, true and true is true, true and false is also false, true. F and F is F, in all cases it is true. Negation of Q, negation of Q, what is negation of Q? For true it is false, false, false it is true, for T it is F, for F it is T. Now, again negation of Q and disjunction P. So negation of Q and disjunction of P means, so again for disjunction false and false is false, in other cases it is true. So false and true is true, true and true is also true, false and false is false, true and false is true. So negation Q and P disjunction false and true is true, true and true is true, false and false is false, true and false is true. Now write down the conjunction for negation P disjunction Q conjunction negation Q disjunction P. Now in case of conjunction true and true is true, in all other cases it is false, right? Now write down the conjunction. So true and true is true, false and true is false, true and false is false, true and true is true. Okay. Now observe carefully this column, that is 1, 2, 3, 4, 5, 6, 7 and 8. Observe carefully, all the truth values in third column and all the truth values in eighth column are same. T, T, F, 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 T, T. That means truth values in third column and eighth column are same. What do you say? That means they are logically equivalent. So therefore they are logically equivalent. That means P biconditional to Q is logically equivalent to negation P disjunction Q conjunction negation Q disjunction P. They are logically equivalent. Suppose if I call this as A and this as B, then A is logically equivalent to B. That's it. This is how we are going to verify. Very important for 5 marks. Now, move on to the next question. Now, here there are P, Q and R. So, the given compound proposition is P conditional to Q conjunction or is logically equivalent to P conditional to Q conjunction P conditional to R, PQR, right? Now, as you know, for PQR, we are going to take the truth values as 2 in the components are 2 into 2 into 2, 2 to the 4 to the 8. For P, it is, as you know, for P, first 4 are true, 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 true. Remaining 4 are false, 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 false. Again, for Q, T, T, F, F, T, T, F, F. And for alternative, true, false, true, false, true, false, true, false. Total 8. 1, 2, 3, 4, 5, 6, 7, 8. Next. So first PQR, then Q conjunction or, Q conjunction or, then P conditional to Q conjunction or, that is first. Then P conditional to Q and P conditional to R, P conditional to Q, P conditional to R, then the conjunction for these two, right? Now, Q conjunction R, conjunction means true and true is true, in all other cases it is false, right? True and true is true, true and false is false, false and true is false, false and false is false, true and true is true, true and false is false, false and true is false, false and false is also false. So, the conjunction true and true is true, in all other cases it is false. Now, write down the conditional for this. So, the conditional for P and Q conjunction are for these two conditional. Conditional means true and false is false, in other cases it is true. So, true and true is true, true and false is false, true and false is also false, true and false is also false, false and true is true, false and false is true, false and false is also true, false and false also true. So, T, F, 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 T, 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 T. This is for P conditional to Q conjunction R. Now, write down P conditional to Q. Now, what is P conditional to Q? P and Q conditional, true and true is true, true and true is true, true and false is false, true and false is false, false and true is true, false and true is also true, false and false is true, false and false is true. So, T and F is F, in all cases it is false. Condition for P and R. P and R, again P and R, P and R, true and true is true, again true and false is false, true and true is true, again true and false is false, again false and true is true, again false and false is also true, false and true is true, false and false is also true. Now, just write down the conjunction for these two, that's all. Now, if you write the conjunction for these two, the conjunction means true and true is true, in all other cases it is false. True and true is true, true and false is false, false and false, false and true is also false, false and false is also false, true and true is true, true and true is true, true and true is true, true and true is. Now, let us represent this as first, second, third, fourth, fifth, sixth, seventh and eighth column. Observe carefully the truth values in fifth column, that is, are same as that of eighth column. See the truth values of fifth column, T, T, F, 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 again T, 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 T. So, all the truth values in fifth and seventh column are same. So, therefore, they are logically equivalent. The truth values, so therefore, truth values in fifth and eighth column are same. So, that means they are logically equivalent. Let us represent this as A and this as B. Therefore, A is logically equivalent to B. A is logically equivalent to B. So, what do you say? We can say that therefore, P conditional to Q conjunction R is logically equivalent to P conditional to Q conjunction P conditional to R. So, these two are logically equivalent. So, this, if you do this much, definitely you will get a 5 marks. This is also very important for the point of examination. Hope you got an idea how to verify the logically equivalence for any given two compound propositions, right? So, this is very simple concept. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.